Welcome to the Explainer. There's this hidden language that describes pretty much everything. The buildings we live in, the art we love, and even the stars up in the sky. That language is geometry. And today, we're going to learn its alphabet, right from the very beginning.
I mean, think about it. How does a massive skyscraper stay standing? Or how does your phone's GPS figure out the fastest way to get you somewhere? Heck, even just describing the path from your couch to the fridge, it all boils down to this secret code. A universal language made of really simple stuff: points, lines, and angles.
So, you ready to crack this code? All right, here's how we're going to do it. First, we'll talk about the language of space, then get into points, lines, and segments. After that, we'll figure out how to measure a line segment, introduce rays and angles, touch on two really important angles, and finally, see how geometry is literally everywhere. Let's do it.
Okay, so what is geometry when you get right down to it? I promise it's not just some dry, boring chapter in a math book. Think of it more like putting on a new pair of glasses. Suddenly you see the world completely differently. It's kind of like the secret sauce that makes everything work.
Yeah, it's the language architects use for those incredible skyscrapers, or that artists use to make something beautiful. And what's wild is that this huge, grand language of the universe, it all starts with one tiny, simple thing: a single point.
All right, so a point is our first letter in this geometric alphabet. So what happens when you string these letters together? What kind of words can you make? Well, let's see. Just imagine a ton of these points, all lined up perfectly straight like they're holding hands.
You get a line. It's basically a perfectly straight road that just goes on forever, in both directions. You know those little arrows you sometimes see on the ends of a line in a diagram? They're not just for decoration. They're there to tell you that this thing never stops. It just keeps going and going forever.
Okay, so an infinite line is a cool idea, right? But you can't really build anything with it. You need something that actually starts and stops. And that's where the line segment comes into play. Just picture taking that infinite line and just snipping out a piece of it. Now you've got something you can actually use. It's got a start and a finish, and we call those the endpoints.
So here's the absolute key difference, right? You can't measure a line. It's impossible. It goes on forever, so how could you? But a line segment, now that we can work with. Because it has those two endpoints, we can actually measure it. We can put a number on it and say, this segment is exactly this long.
Okay, so we've got this line segment. We know it has a length, so how do we actually find out what that length is? Let's take a look.
It's actually way easier than you might think. You just need a number line, like a ruler. You find the coordinates for the two endpoints, basically where they are on the ruler, and then you just subtract the smaller number from the bigger one. That's it.
So it's just a simple three-step process. 1, place it on a number line. 2, find the coordinates of the endpoints. 3, subtract the smaller coordinate from the larger one. You do that, you'll get the right answer every single time.
For example, let's say one endpoint is at position 5 and the other one is at 8. What's the distance? Simple. 8 minus 5 is 3. The length of the segment is 3 units. See? You've already got this.
All right, so we've got lines and line segments down. But what happens when we mix things up a bit? What if, say, you have a starting point but no end point? Or what happens when two of these things meet? This is where it starts to get really interesting.
That's what we call a ray. The best way to think about it is like a beam of light from a flashlight, right? It has one clear starting point, the flashlight itself, but then the light just goes on and on in one direction forever.
So what happens if you have two rays and they both start at the very same point? Well, they form an angle. That shared starting point has a special name. We call it the vertex. And the angle itself is just the measure of the space or the turn between those two rays, which are called the sides.
Okay, so there are countless types of angles, but really, there are two that are kind of like the superstars. They are so fundamental to everything that you literally see them everywhere, probably without even noticing. First up is the right angle. This is the perfect corner. You know, the corner of a book or a square. It measures exactly 90 degrees. And the name actually comes from the Latin word rectus, which means upright. It's basically the foundation of almost everything we build. And what's so wild about the right angle is just how common it is. It's the foundation of squares and rectangles. It's formed by perpendicular lines, and all right angles are equal. I mean, seriously, look around right now. The corner of your monitor, the edges of a door, they're everywhere. A right angle is always 90 degrees, period.
Okay, our second essential angle is the straight angle. And it's exactly what it sounds like. It's just a perfectly straight line. It measures 180 degrees.
And the easiest way to think about it is this. A straight angle is just two right angles side by side, right? 90 degrees plus another 90 degrees gives you 180 degrees. It's that simple.
So yeah, that's the relationship right there. A straight angle is exactly twice as big as a right angle. One is 90 degrees, the other is 180. Simple as that.
So there you have it. We've gone all the way from a single point to the angles that really shape our entire world. Let's wrap this up.
You know, there's a great quote from Galileo. He said, "The book of nature is written in the language of mathematics, and its characters are triangles, circles, and other geometric figures." The point is, these aren't just abstract ideas from a textbook. They are literally the building blocks of the world around us.
So I want to leave you with this. Just look around you right now. From where you're sitting, how many right angles can you spot? I bet you'll be surprised. Once you know what to look for, you start seeing these building blocks absolutely everywhere. It's a whole new way to see the world.